The AP Calculus exam and math in general, we like to solve for unknowns. So what is the value of x type of things. But in these type of problems, we're going to have different values. The function it's still going to be a function of x, but there's going to be some unknown constants. And the question is, based on the properties of the function, what do those constants need to be? It's a very common problem. And so we're going to be doing those, and we've done them in the past with things like continuity and differentiability, which are properties of the function. But now we're going to talk about the function analysis aspect of it, of increasing, decreasing, relative min, relative max, concave up, concave down, points of inflection. Now, most of these problems do deal with the fact of a relative extrema or point of inflection. So, to start off our notes, I want to make sure we note that if a function, f y equals f of x, is continuous, and differentiable, then if the function has a relative extrema at x equals a, then f prime of a must equal 0. However, note f prime of a equals 0 does not indicate relative extrema. So what I'm saying here is that we say that this is a critical point. Critical points are potential extrema. So just because the derivative equals 0, and this is what I was kind of telling you in last week, just because the derivative equals 0 at a point does not make it a relative min or a relative max. It does not, first off, you can't decipher which one it is, and does also not make a relative extrema. However, if there's a relative extrema and the function is differentiable, then it does mean that the derivative equals 0. Now, I state this point about being differentiable because we're going to deal with some instances where the function is continuous but not differentiable, and we'll bring in that. But everything right now that we've been working with is kind of like polynomials, which are continuous and differentiable functions everywhere. Smooth graph. And if there is a relative extrema, the only way there can be a relative extrema is if you have a critical point. But just because you have a critical point does not mean you have a relative extrema. It can go, for example, the derivative can go from positive to positive. The same with points of inflection. If f of x has a point of inflection at x equals a, then f double prime of a must equal 0. But just because f double prime equals 0 does not indicate point of inflection. It's just like when we're justifying, I get a lot of students that, okay, how do we know this is a point of inflection? And they say, oh, because the second derivative is 0. And that's not a justification. You have to check the sign analysis, all right? You still have to do a sign analysis to confirm or determine if a first or second derivative critical point is a relative extrema or point of inflection. But if I tell you there's a relative extrema, if I tell you there's a point of inflection, then given that this is a differentiable function, a continuous and differentiable function, then the derivative must have equals 0 there. Now, you got to be careful of the vocabulary, okay? So remember the difference of versus at. All right? So what I mean by that is if I told you that there's a relative minimum at x equals 5, then what do we know? If I told you there's a relative minimum at x equals 5, what function analysis, what property of the function have I given you? Tells us that what? There's a relative min at x equals 5. It tells me two pieces of information. The first one is the one that we want to know. This is where I need your input. That's the second piece. No, and actually, no, I can't accept that answer, no. There's a relative min at x equals 5. Just take what I've kind of put up here in the notes. There's a relative min at x equals 5. What do I know? A relative min is one of the relative extremas. I see a lot of its in my responses so far. Remember, it will never be acceptable. I either need to see more attempts, you can do a direct message to me, or I need to get a right answer. So I see so many students who are not even giving the slightest bit of a response. That is unacceptable in terms of not attempting at all. We need to get towards that. Even if you don't feel comfortable taking a limb in terms of the chat to everyone, you can take a limb and a chat to me directly, which some individuals have. I need some more responses before we can move on. I'm not just going to give you the answer because, as being noted right now, me just giving you the answers means that you don't know what to do. So you got to be more specific about what that tells me. What does it analytically, algebraically, what does it tell me? Algebraically, if there is a relative min at x equals 5, algebraically, what does that mean? Analytically, what does that mean? If you were trying to find a relative min, what would you do first? What would be the first steps? If the problem was to try to find a relative min, what would you do? And therefore, what does this mean? I need more responses from other individuals. Once again, another it's. Can't accept it's. It's. Had 4 people so far, and every single one has been using it's. And I keep saying it does not ever give you any part. Okay, so we're getting something close now. Okay, so we're getting some attempts. It's very good. It's not the sign analysis of f of x, it's f prime. So what this tells me is that there's a relative minimum at x equals 5. It tells me that f prime of 5 is 0. It also tells me that f prime, and this is what a lot of you were attempting to say, but no one said it correctly that would receive any credit on the exam. F prime changes from negative to positive at x equals 5. Now that's what determines that x equals 5 is a relative min and not just a relative extrema. If it was a relative extrema, that means that there's a sign change. But first and most importantly is this right here. And that's what you're going to have to use to find the answer. If I told you that there's a relative minimum of 18, this tells us that this one's a little bit tougher. This tells me that f prime of x equals 0 gives me x equals a, and that f of a is 18. The output of the relative min. Now I don't know what a is, so you have to figure out where it occurs. So there, you should be able to solve for when that occurs. It might be x equals 4, for example. And that if you plug 4 back into the original function, you will get 18. So relative min of 18 tells you that the output is 18. Relative min at x equals 5 solves it for you basically and tells you that the input value for the relative min is 5. So at is the x value, of is the y value. Okay. So be careful in terms of those that differentiation between those ones. All right. Let's do 2 examples. So in the first example, I gave you that f of x equals x cubed minus kx squared, where of course k is a constant, and I tell you that there's a point of inflection at x equals 1. Find k. Okay. So what do I know? Given this information, what do I know? How do I go about solving this? Okay, I'm going to take a derivative, okay, but what information does this tell me before I start doing that? If you start taking a derivative, you're most likely going to be right in doing that in at least step 1. But let's get a little bit more. What does this information, what does this problem tell me? I can't accept that answer. You just basically said it without not saying the word it. And you have like a double it, technically. There's a point of inflection at x equals 1. What does that tell me? What is the notes? I've already given to you. It should be about as easy as I can give it to you here. Led you to the water. You just got to drink it. We've done the same idea. This is right there in your notes. There's no memory. It's literally right there in your notes. Thank you. F double prime of 1 equals 0. That's sent to me directly. F double prime of 1 is 0. So the second derivative, point of inflections, work but the functional analysis of the second derivative. Now, it also informs me that the sign of the second derivative changes at x equals 1. All right. So that's what it also informs me, but that's not going to be really important here. I just know analytically that the second derivative at 1 equals 0. It's just like I said, it's right there in your notes. Right there. F double prime of A equals 0. Point of inflection at x equals A. If you guys cannot translate x equals A and me then telling you x equals 1 and pulling that in, that's the part where I said has nothing to do with memory. It's right there in your notes. I've given you the answers. There's also that other part, but that's not going to be important because a point of inflection is a point of inflection. There's only one point of inflection for this problem is basically what it's telling me. I don't need to go into anything. I'm not trying to justify the point of inflection, but there should also be noted that there is a sign change for the second derivative at x equals 1. Notice how specific I was. Everybody will lose. You will lose a tremendous amount of points to the point where you cannot pass the exam, or you will lose at least a point or 2 out of 5 on the AP exam just because you keep referencing things to like it. All right. As was noted, let's find the second derivative. Well, we'll find the derivative. So f prime of x equals what? Three x squared. We're going to finish it. You think that's the whole derivative? There we go. Minus 2kx. So that's the first derivative. Okay. But we need the second derivative, so we're going to go to f double prime of x. So the second derivative is if I give you this, and this goes to everybody. If I gave you this and then I said find the second derivative, here's the first derivative. This should be something every single one of you should be able to do instantly. I can guarantee you cannot pass the exam if you're not getting this part right here. 6x minus 2k. You've done this over and over and over and over. This does not get more repetitive of that type of work. Now that we found the second derivative, we're going to set it equal. We're going to utilize what we just found. All right. So we're going to take what we just found, and I like to be a little bit more, using correct notation. So it means that when I plug in 1, I get 0. A lot of people will do, and then they'll do like equals 0 for this, and then I don't like it. I'm not a fan of just plugging and setting this equal to 0 as is. What it means that is if I plug in 1, so f double prime of 1 would give me 6 times 1 minus 2k, and then I'm going to set it equal to 0. Okay? It's not really a biggie if you set this with the 0 with the x and then you plugged in the 1. The idea though is that when I plug in x equals 1 into the second derivative, the output will be 0. 6 minus 2k equals 0. 6 equals 2k, so k equals 3. Okay. That's it for those type of problem, for that type of problem right there. Now, there will be problems that give two properties for two unknowns. All right, so you have to go about doing this as you normally would. So let me just make sure right here. Let me just write down this problem on my own. Let me just do it mentally. All right, so I think I got it. All right, so I'm making up a new example here. So in this problem, f of x equals x squared minus ax plus b. Okay. Pen or anything like that. So the properties of this information of this problem is that there's a relative min at x equals 3 and an x-intercept at x equals 4. Now, they both tell me two pieces of information. So the relative min tells me what? F prime of 3 equals 0. Perfect. The x-intercept tells me what? What's the property for an x-intercept? This is just algebra 1. There's an x-intercept at x equals 4. What does that mean? Almost no difference of what we've been doing so far. Only one little difference. Come on, class. You gotta be able to get a little bit more. Like I said, if you want to just direct message me, I'm not stating your name. I just need to know that you're being active, and I need to see those attempts. X-intercept at x equals 4. What does that mean analytically? How do you find an x-intercept? No. There's an x-intercept at x equals 4. I'm asking about the x-intercept. Okay, good response there. A long response. All that states is that f of 4 equals 0. F of 4 equals 0. Not f of 3, f of 4. So not the y-intercept, it's an x-intercept. And to find an x-intercept, you set the function equal to 0. Well, I've told you where the x-intercept is, or at least one of the x-intercepts. So there's an x-intercept at x equals 4, which means that f of 4 is 0. Now, you might be required to do a system of equation type of problem. But oftentimes, when you're doing these problems, if you take the one that uses the derivative, or in some cases the second derivative, you might actually find one of the answers for one of the unknowns. And that's what's going to occur here. So we're going to take the derivative. We're going to try to utilize this one right over here. And we're going to find the derivative. So f prime of x would be what? 2x minus a. F prime of x is 2x minus a. Now we know that f prime of 3 equals 0, so 2 times 3 minus a is 0. 6 minus a has to equal 0, so a is equal to, there we go, 6. All right, so I got one of the values. I found a, now I need to find b. So f of 4 is 0. So what do I do? The derivative? No. F of 4 is 0. What do I do? And if you use it, or a form of it, or a lack of describing what it is, I'm going to tell you you're wrong. F of 4 equals 0. What do I do? F of 4 is 0. What do I do? Maybe you can call this algebra 2. So for the function f of x, we're going to plug in 4 to the original. I guess I don't like the word original. It's to the function f of x, but I know what you're referring to. So f of 4 would be 4 squared minus a times 4 plus b equals 0. But I know a is 6, so might as well fix that, right? So I get 16 minus 6 times 4 plus b equals 0, because I know a is 6. If not, I would have got a system of equations. I would have had an equation with a and b, and then I would have had another equation with a and b, and had to find them. So that's 16 minus 24 plus b equals 0. That gives me negative 8 plus b equals 0, which gives me b equals 8. So if I went back and I actually graphed x squared minus 6x plus 8, because it was minus a, and I were to graph that, oops, I'll turn that off. This is what the graph looks like. And I can see that the relative minimum occurs at x equals 3. It goes by ones, with the y-intercept occurring right there at 4. Now there's another x-intercept. I could have given you the x-intercept was 2, and mathematically we would have found the same answer. But I got an x-intercept at x equals 4, and I got a relative min at x equals 3 when a is 6 and b is 8. And that's it. So I just found you to find the answers, but in this case the answer really is x squared minus 6x, that f of x, plus 8 would give me these properties up there. So x squared minus 6x plus 8 has a relative minimum at x equals 3, and it has an x-intercept at x equals 4. There's also another x-intercept at x equals 2. It also has a y-intercept at 8. I could have given you that, but if I told you the y-intercept is 8, you'd be like, yeah, okay, b equals 8. Boom, I gave you one of the answers. And that could be a problem that I give you. And that would be a much more obvious problem, because it was like, if I told you the y-intercept was 8, then automatically, almost instantaneously, you should be like, b is 8. You don't have to even do work. You'd be like, oh, y-intercept at 8 is 8. B equals 8 because b represents the y-intercept. Boom. That would be, shouldn't have to do any algebra work. And like, oh, well, if I plug in x equals 0, and then it was like, oh no, that's just the constant by itself is the y-intercept, and then get it done that quickly. That's what I have for you. Your homework is a handout.